Fire alarm systems, so detection and alarm systems. So NFPA 72 is the book that we're utilizing. That is the National Fire Alarm and Signaling Code. I don't have a copy of it. I've handed out all of my books and never got them returned or replaced. So that is one of them that I don't have extras on. The codes that will send us to what is required to have a fire alarm and detection system in a building is going to be NFPA 1, NFPA 101, special occupancy and process standard codes, and then the building codes, the applicable building codes. So the building codes kind of, very much like NFPA 1, NFPA 101 will tell us when we have to have it. And there are cases where the building code says you have to have a fire alarm system, but NFPA doesn't. So again, going down to, and especially for you code officials, when you get the phone call that says, well, the fire marshal's office says we don't have to have it. We always try to throw that caveat in there that we're only speaking on NFPA's behalf, okay? The life safety code says you don't need to have it. But check with the local building official for the building codes because that may dictate it. Or a local ordinance, because there are a lot of municipalities that actually have ordinances for fire alarms. Building over 2,500 square feet, commercial building has to have a fire alarm system. I've seen that in local ordinances. We don't keep track of local ordinances. It would be way too difficult. They get changed on an annual basis sometimes, depending on who's, has an agenda or an axe to grind or whatever. So we don't keep track of that at all. We just defer to the local code officials because you know your ordinances.
So does building code supersede NFPA?
No, it may be more stringent, okay? Most of the time, they're pretty mirrored. They're pretty close. And we've worked hard to get it that way and keep it that way. What happens in the future is tough to tell. Okay? Like I said, NFPA 101 or local ordinances will dictate when a fire alarm system, or going backwards to a sprinkler system, may be required in a building. NFPA 72 determines the how and where. How do I install it? Where do I install it? How do I do inspection, testing, maintenance of it? Different than the NFPA 13, different than sprinklers. Sprinklers has its own inspection and testing maintenance book, which is NFPA 25. Fire alarms, detection systems, utilizes the same book. NFPA 72 covers everything, covers both. NFPA 70, the National Electrical Code, covers the wiring methods. So in order to install a fire alarm system in the state of Maine, you also have to hold a electrical license of sort. Fire alarm systems, if that's all you're gonna do, is considered a limited electrical license. Okay, you have a limited license. Basic components of a fire alarm system, super easy. You have all of your, they have written smoke detectors, but you have all of your detection devices, okay? That is an initiating device. It initiates everything else to happen. It tells us, it initiates that we have an issue going on. So we have initiating devices that sends a signal back to a control panel and says we have to send out and transmit an alarm. It transmits to a alarm notification appliance, an audible or visual or both appliance. On the walls by each of these doors and over here, those are audible and visual. They're horn strobes, okay? They make noise and they strobe. Some control panels and some systems, if it is a monitored fire alarm system, will send a signal out to a central station. That is a monitoring company. Protection One, Seacoast Security, Cunningham Security. Those are approved central stations, okay? They have the ability to receive all of this information and figure out what's going on and send out a signal to alert or call a fire department or some sort of a facility. Some facilities actually do their own central station. You look at a jail, we talked about the Wyndham Correctional Facility. They actually, and you talked about a control room, you know, where they control the doors. They actually have control of the fire alarm system as well. It's constantly monitored by them 24 hours a day, 7 days a week. They have somebody sitting in that seat. They're not only saying, you know, open door number or whatever, you know, to let prisoner whatever into that room. They're also receiving any alarms that are coming in. They determine if there's an issue, they call the fire department. But they're approved to be a central station. So super basic on the components. So initiating devices, they can be automatic. And automatic initiating devices are something like a detector. Okay, detects that there's flames or smoke, sends a signal to back to the system. It could be a manual. This is a manual pull station for those of you who can see it at the doors. Okay, that is a manual initiating device. And then we have supervisory. We talked about supervision of valves, right? We talked about those valves that if you open or close it, it sends a signal. Supervised valves, that is a supervisory portion of a fire alarm system. Notifies that somebody is tampering with the valves. Water flow devices, that little picture that we saw, the electronic control with the inline of the pipe, that moves that flapper, sends a signal that water is flowing. That is a supervisory device. Then we have our notification devices, as I pointed out, horns, strobes, could be a screen. Some large facilities like the Bangor waterfront or the Cross Centers, if a fire alarm goes off, they actually have it on the screen. Fire alarm, emergency, exit the building, you know, walk, don't run, blah, blah, blah. And then we have the processing portion of it, which is the fire alarm control panel. This thing right here. This is the brains. It receives all the signals and sends signals out. So manual pull stations, only used for fire alarm initiating purposes. Hold down to alert. They have to be mounted between 42 and 48 inches above the floor level. As an inspector, and here's a big debate that we've had in past, as an inspector, if I find that it's not installed correctly, that is not a deficiency during an inspection. It's existing, okay? That is, when we're doing an inspection, if it's brand new, you call it out. That's okay. You call out that the installation was incorrect. But as an inspector, I just need to make sure that I have a manual initiating device in place and that it's functional. Has to be located within 5 feet of the exit doorway opening at each exit on each floor. That's within 5 feet of the opening. That one over there is within 5 feet of the opening. Those are correct. We'll do a practice test and we'll see a specific section about that in a little bit. Well, right now. So additional boxes added so that the travel distance to the nearest box is not in excess of 200 feet. This is in relation to a corridor, okay, or travel distance. If I have to travel more than 200 feet in a building without having access to a manual pull station, I have to put one in prior to that 200 feet or right at that 200-foot mark. So if I have a corridor or a travel distance that is 210 feet Is it okay for me to have just that one manual box? No, because it tells us if we're in excess of 200 feet, then I need to add an additional box. I actually have a practice question on this that you will look up. Don't think we'll be able to practice it in class today, but I will send that to you. Mounted on both sides of a grouped opening over 40 feet. Think of a mall setting, big mall concourse, okay? My exits, they're huge. Okay, that concourse is wide. Possibly if it's over 40 feet, then you have to have a manual pull station on either side, okay? The Portland Civic Center, I don't know if those doors are greater than 40 feet apart from each other, you know, or wide, but if they are, there should be a manual pull station on either side of that. And within 60 inches, 5 feet of each side of that opening. Within 5 feet. So I can have a manual pull station, I have to do the math, but you know, this is probably greater than 5 feet here. So maybe one here, you can have, you know, it can move somewheres over, you can't see the screen, somewheres over in this area, within 5 feet. So automatic initiation, smoke detectors are considered automatic, heat detectors, otherwise known as rate of rise detectors, okay? Flow switches, water flow switches are automatic. Here we have some automatic detectors, examples. This is an automatic detector. What is this? Looks a little funky. That is a rate of rise, okay? Rate of rise meaning a temperature. Some of these are resettable or restorable, which is those are important terms. Rate of rise and restorable or resettable. Some of them are non-restorable, meaning they're disposable. If the temperature goes up and they go into an alarm, they get replaced. The resettable, once the temperature comes down, they either reset themselves or they have to be reset. Okay? What's this one?
Is that an infrared? Can't see it.
Photo eye.
Oh, either.
It's a laser or, yes, photo eye type scenario. Kind of like your garage door has a receiver on the other side. You try to close your door and you walk past this, the door goes back up. Same scenario. It always has that beam. You break the beam with smoke, it will go into alarm. How about this one? What's this?
HVAC smoke.
Yep, a duct detector. That duct detector. That's actually in duct work. It has a sensor, a probe that goes in, and it actually sniffs every so often to check. And if it senses smoke, if it pulls smoke into it, it goes into an alarm. Rooftop units, RTUs. If you look at a control panel on a fire alarm system, you'll see RTU1, RTU2, RTU3. Rooftop units, oftentimes. Or duct 1, duct 2. There's new technology that's out there for automatic initiation devices that uses artificial intelligence. Actually, a camera watching the room, it knows what the room is supposed to look like every day. It can actually sense people's bodies, but it actually has thermal imaging where it senses temperatures, or it can tell when something is different. There are new ones out there that can actually visualize and detect a whiff of smoke. Okay, it senses something different. So we're seeing that kind of technology in a lot of the recycling centers because of lithium-ion battery fires and whatnot. So very unique and new type of systems. Okay, NFPA 72, Chapter 17, 177311. There's a reason why this is on the board, in this one, in this one. Okay, the location and spacing of smoke detectors shall be based upon the anticipated smoke flows due to the plume and ceiling jet produced by the anticipated fire. The plume is the smoke hitting the ceiling, going up to the ceiling. And the ceiling jet, meaning as it's spreading across the ceiling. Okay, as well as any pre-existing ambient airflows that could exist in the protected compartment. That's not so much of a big deal. This and this may be pretty important for testing purposes. Okay, so we have to anticipate the ceiling shape and surface when we're looking at installing these, the ceiling heights, the configuration of the contents in protected area, combustion characteristics and probable equivalence ratio of the anticipated fires involving the fuel loads within the protected area. That's just saying that things can get very hot and very quick, very intense very quickly. So the detection needs to be placed and designed accordingly. Again, we're not sprinkler designers here, okay? But we have to understand some of these things.
What edition? In this NFPA?
72 is the 2016? Yeah, 2016 edition. All right, so 17732331 with an asterisk, meaning there's information in the annex about it. In the absence of specific performance-based design criteria, one of the following requirements shall apply. The distance between smoke detectors shall not exceed a nominal spacing of 30 feet. Most smoke detectors, when you open up the package for them, and of course we're talking about fire alarms here, most detectors are gonna give you a specific distance. The manufacturer is gonna tell you what their product is good for. In the event that they don't, that they shall not exceed 30 feet. There are exceptions to this, but as a general rule, won't exceed 30 feet, and there shall be detectors within a distance of 1/2 the spacing measured at right angles from all walls, partitions, blah, 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 extending upwards. I don't expect you to memorize this. I don't expect you to continue to understand the design features of this. But what you may need to do is just recognize smoke detector spacing and their 30 feet versus 15 or 0.7 versus 30, okay? Recognize the question, read the question, and answer based on what you're reading here. There's more information on it as we go. This one here, you'll see something like this on the test. Acceptable areas of where the detector can be mounted. And keep in mind, the manufacturer will tell you, they'll give you the mounting information. If it's a legitimate company, it's gonna meet 100% of this. If there's no information on it, we understand that the ceiling is acceptable. We'll see a little bit, a different variation of this in a second. Somewhere's maximum of 12 inches down on the sidewall. It's just an example of the proper mounting. On the ceiling, on the wall within 12 inches. The next slide will show you where not to put it, within 4 inches of that triangle, because smoke comes up and it rolls. Okay, it doesn't go straight up and straight and then over at a 90-degree angle. Smoke will roll. That's why it's telling you, don't put it within that 4-inch triangle. The important part is, it's okay on the ceiling, it's okay on the wall, as long as it's within 12 inches down and 4 inches away If you have a peaked ceiling, slope ceiling, it's telling you anywheres in this area is okay, but not up here. Again, because smoke's gonna come up and it's gonna roll. It's not necessarily gonna build right in that first 4 inches triangle of the peak. The question may be, in a peak slope ceiling, how far down is it acceptable to put that detector? 4 inches down, 36 inches across. Okay? All you have to do is just read the chart, read the question. This table is what you will probably see for a question. Or it'll ask, what's the heat detector spacing, heat detector reduction based on the ceiling height? If they ask you, they tell you that you have a ceiling 17 feet, your ceiling height greater than 16, but less than or up to and including 18, so 17 falls within that range, you multiply by 0.71. That's all you need to know. You don't need to do the math. You don't need to know any further than that, okay? You just have to know how to read the table. If it's 17 feet, that falls between 16 and 18, 0.71 is your multiplier. That's all you need to know with this table, okay? We're not getting into design criteria here. So, as an example again, if I have a 25-foot ceiling height, what's my multiplier?
0.46.
0.46. Okay, because it falls within 24 to 26. 0.46 is my multiplier. We can get into a lot more specifics in another weeks-long class if we wanted to go that route. That's not where we're going here. Actually, it's more than a week long for design. Okay, everybody understand that? We're good with that table? Okay, make sure you're putting a tab or highlighting table 176351. All right, so we already talked about supervisory devices, but when we're talking about detection and alarm systems, we're talking about supervisories that are devices intended to provide indications of trouble, of off normal conditions from a fire protection or life safety system. Something happens to this valve, it's gonna send a signal. That's a trouble. If somebody operates this valve, that is a off normal condition, okay? Somebody closed the valve or opened it or tried to or played with it. That's supervising that valve. You could have alarms, we talked about water flow devices, activation of a suppression system, special agent type system, those activations, NFPA 96 hoods, the commercial cooking hoods. If there's a fire alarm system in the building that has a commercial cooking hood, it has to be tied together. So it notifies you that the commercial cooking hood system had gone off. Okay? Fire pump running is connected to a fire pump. It advises you that a fire pump is running, maybe in test mode, might be its annual, weekly, whatever test, but it advises you that the fire pump is running. Those are trouble signals, trouble alarms. They may not necessarily call the fire department. Those trouble alarms might notify locally, just to say, hey, there's something going on. We're in trouble here. Something's happening that shouldn't be happening. Or something's happening that's regularly scheduled to happen. Okay, notification appliances, they can be horn strobes like this, horn strobes like this, horn strobes like this. They could be just strobes only, or just horns only. Okay, it could also be screens. So the audibility, the strobe itself or the alarm that's going off, there's two different versions. There's a public mode and then there's a private mode. Public mode is what we're all used to. Goes off anywhere throughout the building. Okay? Fire alarm goes off, you're all hearing it. Private mode, areas where trained staff work who are responsible to aid in the evacuation of occupants. Where would we see a private mode type alarm system?
Hospital, nursing home?
Hospital and nursing home. How many people have been at the hospital and hear ding, code red? That's a fire alarm. Okay? That's not for you to jump out of bed and go running out of the building. That's to notify all of the employees that there's a fire alarm occurring, and maybe we need to get all the doors closed. Maybe we need to take and evacuate all of the occupants from this smoke compartment to another safer smoke compartment. That is what we call private mode. Does not necessarily go into a full alarm like we're normally used to hearing. Okay, they define sleeping areas as rooms where people sleep. That's a good one. Okay. In public mode, fire alarm systems are required to notify in the audible mode at 15 decibels, dBA, over the average ambient sound, or 5 decibels above the maximum level having duration of at least 60 seconds, whichever is greater. In this room here, if we stop and we listen, that's our ambient sound. Okay? Other than me talking, that's probably the loudest sound that we're gonna hear in this room on a normal basis. We go 15 decibels above that sound, or take a reading with me speaking as loud as I am and go 5 decibels above that. That's what has to happen as far as the audibility. Those are the levels. Think about a factory. Okay? Factories can be very, very loud. You have to have hearing protection in just to be in there. Okay? So at the normal ambient level, 15 above that, or whatever the maximum in that factory level may be for 60 seconds or longer, and 5 decibels above that. Does that make sense? Just has to be louder than it normally is in a building, or the sounds that could be lasting for 30 seconds or greater. So 18431 and 18411, because again, they're on the screen, probably places you should be tabbing and highlighting. 18411, where average sound levels are greater than 105 decibels, visible appliances are required. So go back to that factory or that industrial mode again. We have, sounds that are greater than 105 decibels all the time. You have to have notification, visible notification devices available. Typically, that's something that you're gonna see maybe up in the ceiling or up in the roof that's gonna notify what's happening. We take it a little further with the private mode. If the fire alarm does have to go off and activate, it has to be not less than 5 decibels at 10 feet or more, then 120 decibels, and average sound level at least 10 decibels above the average ambient or 5 above maximum sound level with duration of at least 60 seconds, whichever is greater. A little bit confusing on how that reads, okay? Same scenario, 105 decibels above the visible appliance visible appliance is required if it's louder than 105 decibels. 10 feet or more, when they're talking about that, it has to be not less than 45 decibels if I'm 10 feet away from that notification device. Okay, it's the distance away from that alarm that you are, has to be 45 decibels, but not more than 120 decibels. So you don't want it too loud. Let's see. Oh yeah. 18.45 and 18.55, again, important to have. At least 15 decibels above the average ambient, again, normal sounds when it's quiet, that's the average. Or 5 above the maximum sound having a duration of at least 60 seconds. In sleeping areas, that sound above average ambient may be a ventilator machine. It may be, some other type of, an LVAD machine, that helps somebody with their heart, keeps it pumping, whatever. If that's a constant sound that may be a little bit louder, you have to meet these requirements.
Are those allowed to be gradient? Like, you know how, fire alarms in, notifications in fire stations?
Yeah.
Start off quietly and then they grow.
Right? So typically, they're not that way. It's not, there's nothing that says that they can't do that, providing they're meeting the requirements when it first goes off. Okay, so it has to start at a certain minimum to notify you, so you have to be a minimum of that 15 dBA above the normal sound, and then it can grade up from that as long as it doesn't go above, where were we? Basically above the 120 decibels. So it can be gradient at that point. So the sound level of at least 75 decibels at the pillow level of the room. So you're actually gonna take your meter where you would lay your head on the pillow. That's what that means, the pillow level. So you put your sound meter there and sound the alarm to test it. It has to be at least 75 decibels at that location. So visible indicating appliances shall be installed in sleeping rooms per table 18.5572. Anybody that's ever been in a hospital room and the alarm's going off, you might not hear anything other than that one ding, code red. And then you'll have your visible appliances, your strobes will be going off. But 18.5572 tells you that, and you may see this question on the test. (18.5541), and there isn't a lot of 72 stuff on the test, but there's a fair amount. You're gonna find more sprinkler stuff, you're gonna find more 101 life, more NFPA 1 hazardous material stuff than you will 72 stuff, but you will see some. So the figure 18.5541, room spacing for wall-mounted visual appliances. All this is just giving you your room spacing, 20 feet wide by 20 feet wide. That is your square box, okay? As you grow bigger in your box, it's hard to focus on this, but you start off with your 20 by 20 box here. That's what these mean. Then you go to your 30 by 30 box, your 40 by 40 box, your 50 by 50 box. That's giving you your room spacing for wall-mounted visible appliances. Okay? Public mode operating effect must be seen regardless of the viewer's location. In a public mode, wherever I am in this 50-foot room, 50 by 50 room or 40 by 50 room, I should be able to see a visual appliance notifying me. Should be a strobe there. If more than one appliance can be seen, syncing must take place. What does that mean? I'm standing here, I have a visual there, a visual back there, and a visual right here.
They all have to go off at the
They,
same time.
they all have to strobe at the same time, and why? So I don't start doing the flipper on the floor,
Right.
okay? If I go into a, epileptic seizure, thank you, you know, you wanna prevent that from happening. Strobes can cause that to happen. If you have multiple strobes going off, it messes with the brain. It could cause an epileptic seizure, even for somebody that doesn't normally have them. Going back to this, room spacing for wall-mounted visual appliances, all this is telling you is showing you the 20 by 20 box, 30 by 30, 40 by 40, 50 by 50. You go to this table, 20 by 20, 30 by 30, 40 by 40, 50 by 50, and it continues to go. So if I have a 20 by 20 room, I have to have one light per room, and it has to be at least 15 candela. So if I'm in this room here, I have to have at least one light in that room that is 15 candela, CD, candela, okay? Don't have to have 4 lights, and not applicable. Once I get up to a 40 by 40 room, if I have one light, it's gonna be 60 candela, or I have to have 4 of them that are 15 candelas each. Does that make sense? Room spacing for ceiling mounted, that's for wall mounted. If we had a ceiling mounted in this, let's just say it's 50 by 50 room, and we were gonna have a ceiling mounted 50 by 50 room, the maximum height of the lens, so where that light is mounted, 50 by 50 can't be any greater than 30 feet high. Okay, so 30 feet or less. And my light output has to be at least 95 candela for that one single in this 50 by 50 room, if it's on the ceiling. Does that make sense? Okay, so now you know how to read these tables, but these tables are important because you may have that same scenario. It's gonna say if you have a 50 by 50 room, what's the candela rating or the maximum height that the ceiling has to be, you know, for that 50 by 50 room if we're ceiling mounted. If we're wall mounted, 50 by 50, one light has to be at least 94 candela, or I have to have 4 30s in there. Okay? So we just need to know where to find that. This is a lot of information to take in. Totally get it. Your
Like
mind's
sucking out
at-
of a fire hose,
What's that?
like sucking out of a fire hose.
Yeah, exactly, exactly. Off-premise notification. Central station, remember we talked about that fire alarm system. It's gonna call out and say, hey, we have an emergency here. Alarms are going off. Something's happened, troubles are occurring. It goes out to that central station. It could be a remote supervising station. It could be a proprietary supervising station. Okay, requirements for the installation of all that is in chapter 26. One of the test questions or practice questions that I have provided you, or I will provide you, is gonna ask questions about this and make you go find it. Because I want you to find it. There's a reason why I want you to find it, okay? One, it's all about how to find it, navigating the book. And 2, because those questions are on the test. And maybe as simple as, again, what are the 3 types of notification systems? Okay? Central station, proprietary supervising, and remote supervising. It's gonna ask you those, and it's gonna throw in some odd ones that don't go there. Kinda like, one of those things don't fit. What's that, Sesame Street?
Oh, one of these things not like the other.
You have kids much younger than me. Yes, one of those things not like the other. All right, fire safety functions, elevator control, door releases, stairway pressurizations, smoke managements, initiation of special suppression systems, emergency lighting, unlocking of egress doors, emergency power or fuel shutoffs. All of those things can be connected or should be connected to the fire alarm system. I may have a door that is held open with magnetic door hold opens. Those doors may shut when the fire alarm goes off. Maybe I can't go through those doors on a regular basis. The fire alarm activates, those doors unlock, and I can go through those doors now. Okay? NFPA 96 commercial cooking hood. If there's an activation of that hood system because of a grease fire or whatever, the emergency power shuts off. Or the fuel system, the fuel source shuts off. Gas valve, whatever. And it notifies that there's something happening. Smoke management. Maine Medical Center has a smoke management system. They have a control room for the fire alarm system. You can control the smoke system, stairway pressurizations, or the atrium smoke removal. Okay, elevators, typically if the fire alarm goes off, the elevator goes into a mode, a recall mode, where it goes back to a specific floor designated by the fire department. Because as fire chiefs, you want to be able to send your crews in and potentially utilize that elevator. Elevators generally are not a required means of egress, so people don't get in them. It's gonna go down to that specific floor for the fire department to use. They stick their key in, then they can use it. All controlled or all part of a fire alarm system. How are we doing here? Oh, okay. Not as good as I wanna be. So, we'll keep moving. Every plan should have a legend showing you what all of these symbols mean when you see them on the drawings. Okay? RTU7, rooftop unit 7. SD, look over here, wherever, SD, smoke detector. Okay? F, just a plain box with an F. Manual pull station. ANN, that doesn't mean that Ann stands there or that's her desk. That is the annunciator. K, Knox box, showing you where the riser is. FCPS. FCPS, looks like a booster panel. Probably for a booster pump for the sprinkler system. F with a triangle. ADA horn strobe device. Okay, set of plans. This is very common. Most of the time, Josh and I don't get plans that say all that stuff on it when we get a building that has a fire alarm system in it. So we have to send a deficiency list out. Please provide a set of drawings indicating location of the fire alarm devices. Very much like a sprinkler system. Sprinklers, the RMSs have to sign off, they have to do their final testing. So doesn't a fire alarm system. This is a record of completion. Property owner's information, service testing, monitoring information, installation gives all the address and contacts of those. The documentation, is the documentation there? Yes, it's all provided. Documents are super important with a fire alarm system. The design of that, all the documents that go along with it, indicating what the devices are, very important to have all of that. Should have the record drawings, the as-built drawings should be the final set. Description of system or service, how they're using it, software or firmware information, alarm verification, make sure everything works. For software-based systems, there should be a thumb drive, CD, or something kept. The owner should have a copy of that, because if that system should fail, something should happen, they should be able to completely rebuild and reboot the system, kind of like a flash drive. You flash the system, reboot it, get it back up and running just as it was supposed to be designed. That should all stay with the fire alarm. You find a fire alarm system, find the fire alarm panel. Technically, there's supposed to be a box that looks similar to the fire alarm panel next to it that has all the information in it, the record drawings, all of the certificate of completion, all of the device information that goes along with it, possibly the software-based system records in there. It's under lock and key in that box. By code, that's supposed to be there. Years and years and years and years of inspections have gone by, and that box is not there. We're finding that all the time. But the code says it has to be. So obviously the detection, inspections, testing and maintenance of a fire alarm system is critical to the operation to ensure that it's gonna run and ensure that it's gonna continue to work over the lifespan of the system. All right, so kind of like the, well, I think we saw some other pictures for sprinklers. Kind of like sprinklers, we have causes of failures. Here are some examples. Okay, what do we see for things here, first of all, and what things cause failures in a fire alarm system? Throw them out there. Improper maintenance. Yep. Overly zealous maintenance people.
Lack of paying their bill.
Lack of paying their bill is a huge one. Absolutely. The system may still work, but it's not notifying, it's not monitored any longer. So it's not calling out like it's supposed to. Very, very critical for certain occupancies that require monitoring by our office, by code, by state statute. Absolutely.
So Mark, if a building, like, if they don't pay the bill and it's not monitoring and it's required,
Yep.
is that something where we would call you and you guys could shut their business down?
No, that's your job.
Okay.
Yep.
Code enforcement officers can do that.
Yeah.
Yeah.
You're the AHJ. You're the authority having jurisdiction in your community. You have more authority than I do. If you don't get anywheres with it, you call us, then we'll come in and deal with it.
I
Okay.
shut Funzie down and listed multiple times.
Yeah.
Not naming any names, so anyways.
I do it.
All right, so maintenance, overzealous maintenance, not paying your bill. What about this? Construction occurring. How well do you think that system's gonna work here? Doesn't look like there's anything protecting it from the elements above or on the sides. I mean, we have an open electrical box that's just dangling, okay? Don't think that's gonna be super reliable. I don't even know if all the wires are connected. Not good. Sprinkler system, kind of the same scenario. Not a good scenario to run into. How about this? This says not in service, not in service. Don't look at the mounting of it, that's a different story.
You could have for building maintenance, so like you have water leaks, structural decay that's impeded upon the system.
Yep.
So should that not have a lockout tagout?
Well, lockout tagout would be back at the electrical panel, you know, you'd lock out the main breaker. But, if you see this, does that mean that the system's not in service?
No.
We don't know. Could this be done maliciously? I'm somebody, I'm gonna cause some issues, I'm gonna tape this in, not in service, and I'm gonna go around and create havoc, whatever that may be, right? And then people are gonna be running out, panicking, whatever, don't pull the alarm system because that's gonna notify somebody. That could be very malicious, right? I don't, as the person that's being malicious, I don't want anybody to know that I'm in this room or in this building, running around with, you know, a machete or whatever, okay? Can't always take that for granted. You see something like this, you better be asking an awful lot of questions. All right, so fire alarms, key part of the built environment. They're super important. If they're there, if it's there, it has to function. Just like a sprinkler, if it's there, it has to function. Just like an emergency light, exit sign, doors, they have to function. Fire alarms can operate in public or private mode. Public is gonna notify everyone, loud, horns and strobes going off. Private, it's quiet, you may not know. Off-premise notification is normally required. Most occupancies, it's not just gonna ring locally. It's gonna ring locally and it's gonna call a central station or a supervised state, supervision station. It's gonna notify a fire department. Portland calls, it notifies the fire department. Their system is all integrated. I believe everything calls the fire department in Portland, if I'm not mistaken. Waterville used to be that way. I think they're getting away from that. Spacing is critical on fire alarm devices, just like sprinklers. You don't want them too close together because it'll cause something not to work. You don't want it too close together for a number of different reasons with a fire alarm system. Super important to maintain it, okay? 72 has the requirements for the installation and inspection, testing, and maintenance, all in one book. And then lack of maintenance is the leading cause of failure for fire alarm systems. All right, so we're gonna bounce through after lunch. We're gonna bounce through fire extinguishers really quick.